Welcome to Just Now Possible with Teresa Torres.
I'm Hamel Husain. I've been working in machine learning and AI for over 25 years. I've worked in a lot of different industries across the years. I've worked a lot in tech as well. So I've worked at companies like GitHub and Airbnb. At GitHub, I led research that was a precursor to GitHub Copilot. So I've been working on large language models for a long time. I'm a machine learning engineer, data scientist by training. More recently, I have become an independent consultant helping people with AI. And what I discovered in consulting is the things that people struggle with a lot are how do they improve their AI products, like past the POC stage? Like how do you actually, number one, know it's working, and number two, have some way to stop guessing and improve systematically. And the reason I latched onto that, I think, is because of the data science background. That's the same problem. That was the core sort of work to be done of a data scientist or machine learning engineer. If you're like building before ChatGPT or whatever, if you're working on machine learning, you had to make sure that you had a way of improving a model and measuring it. And it was the same, very similar, like stochastic systems, non-deterministic outputs, things like that. And it turns out you can apply a lot of those things here if you're using like large language models. So I help companies who get stuck there. And it just turned out that most companies, I found when helping companies, like that is the place they get stuck, in this very specific area. And there didn't seem to be too many materials or too any like specific guidance, like how do you do that for whatever reason. And so also teach a course that helps people learn those skills without learning like everything about data science. Like, how do you,
I want to dig into this a little bit. So we're mostly going to spend our time talking through a feature, like a product, an AI product that you built. But before we get there, I took your course, and one of the things that really surprised me was it feels right now like everything is new. We're all learning what LLMs can do. We're all learning how to get good value out of LLMs. I think at the time that we're recording, we're coming up on 3 years of ChatGPT even existing in its current form. And I think what surprised me when I took your course was realizing that a lot of what you're teaching was actually grounded in data science and machine learning. It's not like it was just brand new with AI products. And so maybe I want to make sure that I even have a good mental model for what it means to be like machine learning and AI and data science. So like I used to work on a machine learning product where we matched college students with jobs that they could do. And so like the problem we were trying to solve was if you go to a job board, it asks you, where do you want to work? What do you want your job title to be? And where do you want to live? But if you're 22 years old and you just graduated from college, you actually don't know the answer to either of those questions. You don't know what types of jobs exist. You don't know, you live in multiple places, usually wherever your friends are going. And so we had this idea of, as adults, we know more about what's available, and given a degree, what you could study or what field you could go into. And we could use like a machine learning model in the background to like classify jobs based on students' majors. And we came up with that idea, and no one in my company knew anything about machine learning. But we had a math major from the University of Washington who was like nerding out on some of this stuff. And I was like, hey, just go figure it out. And we actually, the two of us worked on an early like machine learning model. And it was fun to get into it because I think what we both learned is like the really basic things you learn in school around some of these ideas hold even in very complex products. So like we weren't doing anything as complicated as I know Netflix did I think it was their $1 million prize contest of movie recommendations. And this stuff can scale to be like very meaningful and like high business impact. But like at its core, the way I think about machine learning is often as like classifying things, clustering things, matching things. Is this the right way to think about it?
Yeah, it's really machine learning is various predictive algorithms that try to do exactly what you said, recommend things, predict things, forecast things, classify things. And it's like messy.
Yeah.
And the skills you develop as a data scientist is primarily how do you debug that?
Yeah. Okay. So let's take an example. Like give me an example of something you worked on, like a machine learning project that you worked on that we can talk about. Like, what does it mean to debug it? And then I want to get into your AI feature.
Yeah. Okay. One fun one is like when I was at Airbnb, I was working on guest growth. So there's like host growth and guest growth. And one of the things I was in charge of is forecasting lifetime value for each guest so that they could allocate marketing spend effectively. And it was a kind of a complex, there's a lot of different signals that people have, like with their intent, what kinds of properties they're booking, what they're looking at, their whatever information they're giving to Airbnb, so on and so forth. And okay, like it sounds straightforward, right? Oh, great, no problem. Take this, do a forecast, and you're good to go. But it turns out, and it always is the case, that a lot of the sort of work to be done is like the data work. Okay, what data do we have? What are we looking at? And there was a lot of, at the outset, there was a lot of signals in the data that kind of needed to be cleaned up because there was like signals like from the future of what someone did, like bleeding their way into like the training data of the forecast. So things like, there's like silly things like, did the customer deactivate their account, was like hidden somehow. It was like there were some signals of like their last activity. That field would be like become null or something. And so it would turn out like the forecasts that like they had in place were like pretty accurate, a little bit too accurate. And then you had to put on your skepticism hat and look at this data very carefully and say, what is going on here? Why is it very accurate? But in production, in real life, it doesn't seem to be that. And then you have to debug things. So this is like very classic. That particular problem is called data leakage, where you have some kind of data that's leaking where it's not supposed to. That's a very common problem in machine learning. But beyond that, there's like a lot of different, you have to put your skeptical hat on. It devolves in some sense to the scientific method or thinking like a scientist.
Yeah.
And what you want to do is you want to prove to yourself at every kind of juncture that what is happening makes sense, right? So it's not just like debugging algorithms. There's also, once I found that, then I became skeptical of everything. And I thought everything is broken. And then I started debugging all the data for everything. So the goal of that job was to help with like marketing, spend, and allocation. And it turned out, okay, there was some paid advertising spend, and we were sending some conversion signals to Google and other advertising partners. And then we were also in our forecasting, we had the same signals. How many bookings did this person have, or what were they doing, whatever, when you were trying to forecast the lifetime value. And just got out of skepticism, right? So let me compare those two numbers. They should be the same. I was like, no, they're not the same.
They're never the same.
And so this is a very simple examples. Over time of being a data scientist, then you get very attuned and you develop a nose for, okay, how do you dig into data? Where should you be skeptical? And then you get all these tools at your disposal. Like you mentioned clustering, for example. Clustering is a nice data exploration tool. Oh, let me explore the space in some structured way. There's no right answer necessarily, but it's okay, let me do things. And then you have all your technical tools at your disposal and various statistical methods that you could use to dig into data.
So if we take this example of trying to understand marketing spend and what's effective, can we predict impact on lifetime value? I'm assuming part of this is, are they going to be a guest a second time, a third time? I can see like my brain immediately wants to turn this like into a model. Like I'm going to be in a spreadsheet. I'm going to come up with some variables, but that's not what's happening in the machine learning solution. Like you're training an algorithm that here's a bunch of people that had a lifetime value of a certain amount or that churned, or tell me a little bit about what is the machine learning piece doing in this model?
Yeah, so it's really like you have a bunch of features, like all these different attributes about a person, their historical spend, their demographics, their activity on the platform, even pre-purchase or anything like that. And it is conceptually very much like a spreadsheet. It's like, so the simplest like machine learning is like a linear regression. What you may have encountered before is you have a spreadsheet with a bunch of columns, you can assign a weight to every column and have a score.
Yeah.
And essentially,
we're looking for like correlations between things.
Yeah, it's okay, this thing is correlated with higher spend and this thing is correlated with lower spend. And you can get really deep into it. And there's linear regression is like the most classic form of things. But then there's all kinds of other algorithms that have all these other properties, and you can try all these other algorithms. And essentially at the end of the day, you need to test all this stuff, right? Like you need to say, okay, there's a forecast. How do you know the forecast is any good?
Yeah.
And because it's a black box at the end of the day, you have this black box that's giving you a forecast. Okay, that's great. Can you rely on that forecast? And that's the kind of crux of every machine learning problem is, does your model generalize to unseen data? That's the core problem in all of machine learning, in all of AI, really. And you have to measure that to gain confidence. And it's not about just gaining confidence. Like you have to look, obviously, like it's almost impossible to do it the first time.
Yeah.
So you have to take that, so the forecasting example, you have to carefully hold out some data that the model has not been trained on. And that's very easy to make a mistake there, because like the data leakage.
Okay, let me, okay, I think I understand, but I want to just make sure, because I want to use this as the foundation for then moving into an AI product. This is really great. Yeah. So I could just, as a human, sit in front of a spreadsheet and come up with, let's just say, a crude model for how I want to forecast, let's say churn here, because churn is directly related to lifetime value. So you are a guest once, you never come back. And maybe I'm trying to model that against, you're a guest, you come back all the time, or you come back once or twice a year, or whatever the case is. I could see how I could think about this in a spreadsheet and come up with different variables, and I'm looking for correlations. I'm just looking for, and then I might conclude, I think these 5 things predict lifetime value. And I have my model. And there's no machine learning involved, right? Like I just have data, I'm looking at it. I personally, as the human, generated the model. In this case, you're saying with machine learning, like you're giving a bunch of data. It's almost like you're classifying a little bit, like the machine learning algorithm is getting a whole bunch of data about different users, and it's making a prediction about whether they're going to churn or not, or what their lifetime value might be. Is that fair?
Yeah, in the classification or the regression case, it's okay, you have this giant spreadsheet, and then you let the algorithm basically minimize the difference between the actual number, the ground truth, and like the forecast, and keep tweaking, like automatically tweaking the parameters so that,
and that's
like,
when we talk about weights, we're talking about weights on those different variables. We're going to weight this a certain amount, we're going to weight this a certain amount. So I have maybe the time of year that you rented a place, and whether or not you were recommended by someone, like whatever the things are. And the machine learning algorithm is determining how much to weight each of those things when making its forecast.
Yes.
Okay.
And there's a very crude, you can you can actually do this in Excel directly. Yeah. There's like things. And you can do it like very easily on single variables. There's something called goal seeking. Yeah. So make a number, tweak a variable to reach a goal.
I love this because as an undergrad, I took a class where I had to implement like the simplest neural net. It had 5 weights, I think. But like when we got into our college matching thing, I was like, oh, I actually understand this, because conceptually it's exactly the same thing. The complexity of it goes up, but like the underlying conception of, you got a bunch of variables, you're going to weight them differently. You have an input, it calculates something, you get an output. Like it's not it is very analogous to this model in your spreadsheet. The difference is the algorithm is determining the weights. It's helping you figure out how to, given an input, what should the output value be?
Yeah, and it turns out, so like large language models, they're doing a classification, but one token at a time. Yeah. Saying what is the next word and classifying that.
Yep. And given some inputs, run it through all your weights, make a prediction about the next word.
Yes. Yeah.
Okay, I think we just dramatically simplified machine learning, but I think this is going to be a good foundation for, so when you're working on a forecast model like this, I imagine like when you talk about, you got to look at the data and do some error analysis, you're looking at where did the forecast deviate from reality?
Yes.
And you're trying to figure out like, what is it in the data that led to this?
Yes.
But what confuses me a little bit about this process in the machine learning world is if the machine learning algorithm is setting the weights, are you looking at are you tweaking like what the training inputs are to try to fix the output? Are you changing like what data it's working with? Like when you identify a problem, tell me a little bit about that problem solving process of like, how are you fixing things?
Yeah. So a lot of times it's looking at the macro and the micro. So it's like, hey, let me look at the distribution of the errors, like in the training set and in the held out set. And let me see, oh, is it like a completely different shifted distribution? And if so, something went like wrong here. Like maybe the data in my training set has been normalized or some pre-processing happened to it. They're like, whatever. And a lot of times you want to look at individual predictions and say, okay, the forecast for Teresa, her LTV shows that it's going to be like $1,000, but she didn't have any like activity at all. She just signed up for Airbnb. That doesn't make any sense. That doesn't intuitively make sense. Like why? Or didn't you dig into like why is that happening? That doesn't make any sense. Like where is that going? And then you would start debugging. In this situation, you would say, okay, which one of these features would actually led to that prediction? And then you would start debugging like what is going on.
Okay, so you might be figuring out, as part of that analysis, first of all, you said two things. There's this like data set view of is everything shifted, which is more of a macro view. And then you have this micro view of we have an error case. We know the prediction was wrong. Can we dig into that and figure out like, are we missing a feature? Did it get the data for a feature wrong? Do we have a inherent data problem? And so that's helping guide with what would we need to change to make this work for this data point.
Yeah. Like, okay, how do you find that? You can say, let me sort the data by where the forecast is most wrong versus the ground truth. So like the ground truth of Teresa lifetime value is $200, but I'm like forecasting $20,000.
Yeah.
Maybe that's the top error in one direction and whatever. And then same thing for classification. For classification, you'll get some score and you say like, where is the model most confidently wrong? And you can sort by that. So there's techniques you can use to explore the data to see, okay, let me debug like what happened here and see if I can figure out.
Okay, I'm already seeing a lot of parallels with AI products about looking at input, output, pair mismatches, error analysis. So we'll get into all of that. Okay, I think my takeaway so far is I think I want to be a data scientist, one, because it sounds really fun. And two, I think what is important and why I wanted to dig into your background a little bit more than we normally would is I think it's important to recognize like machine learning products have been around for a long time. And there's a whole practice around this. And that LLMs introduce some differences, but we're really building on a really strong foundation of like how to get good quality output from non-deterministic algorithms.
Yeah, that's right. And there's some very simple tools. So it turns out in data science, the joke is counting is incredibly powerful, just counting. And it turns out that is one of the most powerful tools when it comes to debugging LLMs as well.
All right, let's get into this. Okay, so I know you have worked on a lot of AI products, and especially in your consulting work, you've done a lot in your personal work. Give me a little, I think we have one product in particular we're going to talk through. Give me some context. Tell me a little bit about the company, the product, and then and a little bit of context about how you worked with them.
So this is one of the companies that reached out to me for help when they were building their AI product. And so it's called Nurture Boss. And Nurture Boss is a sort of AI assistant for apartment complexes. In other words, multifamily. And so what it does is it helps act as a middle, sort like a first line of defense for like customer service issues that you might have for an apartment you're either interested in viewing or one you're living in. So things like, they list out some of the features here. So helping you with leads. So this is like leads. Then they also have stuff about payment collections, following up with people, resident communications, questions about move-in, maintenance, so on and so forth. So just a lot of the interactions you might have with like your apartment leasing. Okay, can you handle especially common questions that you answer over and over again? Maybe you shouldn't be doing that. That's the thesis.
This resonates with me because when I was in Portland, I lived in like an apartment building with 300 apartments. And we had one leasing office employee who was there. And if he was like showing somebody an apartment, he wasn't available to anybody else. Yeah. And there's always a million questions like, did my package arrive? When's my rent due? Is the guest apartment available for this weekend? And that's while you're living there. And then while you're looking, if I want to look at a 2-bedroom, what's available? When can I come look? That kind of stuff. Yeah. It looks like this company sells this product to apartment management companies. Is that true?
That's correct. So like the customers are the apartment management companies, and they can embed this bot in their website.
Okay. So was this an AI native company, or did they have a different business and they added this to the different business?
No, it was totally AI native. They started from the ground up. They built it for this purpose. So it wasn't like something else and they're like, oh, we need to do AI now. This is like an AI. It's definitely AI first.
Oh, okay. And is this a startup? Is this a small team?
Very small team. At the time, a year ago, it was about 5 or 6 people. Okay. So pretty small. Let's see, maybe they have about us. Yeah, so it looks like they haven't grown too much, but this is the person I was working with, Jacob. He's CEO. And he's also was the engineer, as many startups are, CEO, engineer, everything. And he was building the products and he had some other engineers working with him. But
and does he have a background in this problem space? Like, how did he land on this as a problem for AI to solve?
I think Jacob's background is building web applications. They actually taught people for a long time how to build web applications. And he's like he was like an educator for a while. I believe his co-founder had this struggle of servicing residents and things like that. And they partnered together, him being the technology mind and and then they fused together. He has a pretty good knowledge of the space, like at this point, like when he came to me, because he was like working on it for a year before about a year before he got in touch with me.
Okay. So this sounds very much like this solution was inspired by what AI makes just now possible.
Yes.
Okay. I love this because there's a saying that boring software is often the most profitable software. And I feel like this is a very good example of like very specific targeted market, very specific use cases, a clear need. And it sounds like because it was AI native, they didn't go through this process of is AI the right solution for this? They just thought, this is a match. We have this new technology is available. We know this problem domain. Let's see what we can do.
Yeah, they had a very strong thesis. And they said, look, we already know that this is needed. So we're going to go for it. We're going to build it. And yeah, they really focus on this specific use case. So for example, it's not just of the website. They also give you text and voice agents that residents can interact with.
Okay.
Because that's what people want.
Yeah. They're used to calling the office.
Yes.
Okay. So I can imagine this is a tool that, whether it's literally an agent or not, is from a consumer standpoint, it probably feels like an agent. And I know one of the challenges with these types of AI products is that the scope can just be all over the place. Do you remember what did they do to start to think about what should the scope of this thing be able to do? What use cases are we going to cover? Were you involved at that step?
Yeah. So they tested it out on some very specific workflows first. So tour scheduling is a big thing. Okay. You shouldn't have to call a human, hopefully, to do tour scheduling. So all the appointments and the tours, that was definitely like one of the sort of main first things.
Yep.
And then they grew from there. The things like general questions about a property, specials, pricing, things like that. And they grew from there. They kept adding. So they started off very much with synthetic data and some partners, like early partners. And then they grew from there and they kept going.
When you say early partners, is that like people running apartment buildings?
Yeah, yeah.
Okay.
So like they had some multifamily properties that they were working with early on. So they were able to bootstrap off of some real user data.
Okay, so they had some early customers from their standpoint.
Yeah.
And they really started, it sounds like, with a very narrow use case of just tour scheduling. Did they get a product live with just tour scheduling before they added on, or was this kind of like in research mode?
I don't know. I think they actually went live officially with a lot more features at once.
Okay.
But I think they had some friendly partners at the beginning that were more willing to, like design partners essentially that were happy to put it through its paces. But they did also a lot of hammering at it with like synthetic data as well.
Okay. Let's talk a little bit about synthetic data, because I actually don't think that's come up in our previous conversations on this podcast so far. So the idea was maybe give an overview of what did they use synthetic data for? How did they generate it? Why was it helpful?
Yeah. It might be helpful to show you what the data looks like and then tell you why that helps set the scene of like why synthetic data is useful. Yeah. So you can get a idea. So when we first started working with NurtureBoss, they've used this platform called Brain Trust. And it really doesn't matter the software per se. So you have data, and each of these different rows are one interaction or a complete interaction flow that a user is having with their product. So let's look at one. And what these logs show is like a complete sort of view into what the LLM sees and how the LLM responds, in addition to all the intermediate tool calls and retrieval and anything else that needs to be done in the user interaction. So let's just look at one and then we can go back to what synthetic data is. So here you have a system prompt. And this data is anonymized, by the way. I have permission to share it. Yeah. We have cleaned it. And so thanks to the NurtureBoss people for being generous in this way of allowing this as a teaching example. Okay, the system prompt, you are an AI assistant working as a leasing team member at an apartment complex. Your role is to respond to text messages from both residents and prospective residents. Your goal is to blah, blah, blah. And like sets the persona of this assistant, right? And it sets some rules. For example, if an existing resident asks to make a maintenance request, respond with this link. This is an anonymized link. This is part of the anonymization of the data. And then applications, we're going to provide floor plans. So there's a lot of information in here. And the user shows up, says, hello, what's up with the 4-month rent? So it's pretty realistic. I think this is it's a real interaction. And then there's a tool call made by the assistant, and it's calling this function get communities information. And the get communities information tool it's getting specials and concessions. And then the tool call result is this that you see here. And then, so this is not shown to the user. This assistant and tool call is not shown to the user. That's internal. Yep. And then you have the assistant response. Hello, we are currently offering up to 8 weeks free rent as a special promotion. So that matches the tool call result here. And so if you're interested, I can help you schedule a tour. Okay. Now,
what I love about this already is you're starting to get into what I was going to ask you next, which is just how this was implemented. And it looks like from this trace, this is truly an agent. It has some instructions in its system prompt about what tools to use when, but the agent is deciding, based on this input query, I need to call this tool. It's calling the tool. It's getting the response. It's deciding how to integrate the response into its response. Is that true, or is it a little bit more workflowy where it's told specifically what to use when?
No, it's deciding what tools to call. In fact, there's a list of tools down here in this metadata. So this metadata part of the trace, we have all the different functions. So there's a get individuals information function. There is a get resident question information function. There is a get communities availability, and so on and so forth. It goes on. Like there's a lot of different functions you can call.
Okay, already I have a question about this. So
Yes.
part of the reason why I'm like someone with a discovery background is so interested in AI products. Like you're building an agent that has pretty broad abilities to respond to things, which means I feel like to build this product well, you have to have a really clear understanding of what the end user might ask for. And like it looks like the tools are really closely designed with what you think the use cases are going to be.
Yes, that's right.
Okay. But earlier you shared they started with just tour scheduling. So I imagine like when they first started building, maybe there was one tool. And then as they uncovered more use cases, they added more tools. In the early days, like was the LLM always good at knowing what tool to call, or was there initially, like I'm hearing from a lot of teams, they're starting with like workflows and maybe classifying queries before they get to fully agentic. Okay, you pick the tool. What did the evolutions of this look like?
Yeah, I'm not exactly sure the exact evolution because I wasn't there for the whole thing. They came to me when they had this built out and they were stuck. They had these tools that worked, but they were like, it's not working. It's not working very well. It's working, but I don't know what to do now. Do I just keep changing the prompt? Every time I change the prompt, something else breaks. And I don't really know if it like actually fixed the problem. And I'm paranoid that like when I fix one problem, I'm causing another problem. And so how do I gain my sanity back?
Yeah. Okay, this really resonates with my own personal experience. So it sounds like at the time that you came in, they already had an agent, it had access to tools. It was designed to cover a wide variety of use cases, and it had tools associated with those use cases. And it was deciding itself which tools to call.
Yes.
At this point, were they working with their design partners and it was being used by their end users? Or were they, and it wasn't like meeting their expectations? Or did they just know from internal testing it wasn't good enough and they weren't sure how to get it over?
Oh, they knew. Yeah, they knew internally. They're like, they felt that, hey, we don't really have a handle on if it's good or not. We just feel that it's not good, but we don't even know how to measure. Like, how do we put a number on this? Yeah. Or how do we know from day to day whether we're improving?
Yeah. Okay. The number one thing I'm hearing from teams is it takes an hour or two to get a pretty snazzy demo, and then it takes 8 months to get to something that we're confident is good. So it sounds like they were in this mode. We can see some potential here. We've got some tools. We're covering some use cases, but we're really worried of, is it good?
Yeah. And the team was like really impressive. They built all this stuff and it was all wired together very nicely, honestly. And it did kind of work. It mostly worked, but there was problems, right? And so how do we know what those problems are? How do we get better? So on and so forth.
Okay. I think one thing I want to highlight about what you just said is there's always problems. Right? Yeah. I don't know. Do you know of an AI product where there's zero problems?
No. If there's zero problems, then you should probably be looking at building something else.
You probably have a measurement problem, is my guess.
Yeah. Either there's a measurement problem, or there's usually a measurement problem, like 95% of the time. But if it's so trivial that there's no problems, then you need to think harder. You need to add more value.
Or maybe talk to some customers because you don't know what their actual experience is.
Yes.
I gotta always throw in those little discovery tips every once in a while. Okay, so you're brought in to help a little bit with, this is your sweet spot of how do we know if our AI product is any good? It sounds like, did you start with, let's build out some synthetic data so we can get better test, like measurement coverage?
So at this point, and everyone's a little bit different, I did do some synthetic data for targeted things. In this case, we don't see it here in this specific. We might come, if we do look at enough of these traces, we'll probably see this error. But they had a bunch of these traces already.
Okay.
And then they had some specific errors, like date errors, where a resident wanted to schedule something for some time in the future. Hey, I'm looking for something like 2 weeks out, the beginning of next month, next year, so on and so forth. And the AI was like not getting the date correct exactly. It was like fumbling the exact date.
Yep.
And so, okay, let's create a data set. So going back to synthetic data, what that means is, can you generate plausible user inputs into your system? This is one, hello, what's up with the 4-month rent, to stress test your system. But you don't want to necessarily do that blindly. There are ways to get started, which we teach in our class. But it's always good to have a product, have some hypothesis, because the reason for doing the synthetic data is to try to explore an error or try to really push on something that you feel like has a high chance of breaking. That's the best.
Yeah.
That's the best kind of synthetic data.
So if I saw evidence of this date problem, my goal is to generate synthetic data that helps me understand, like, where are the boundaries of this error? When does it show up? When does it not show up? So my synthetic data might be looking at like different date formats, how far out into the future, how near in the future.
Yes.
Right? So I'm looking at like...
Yeah, leap year, crossing the year boundary, being very vague about like different ways of talking about it, like a few weeks. What the hell does a few weeks mean? We don't know. Like we maybe know, but it's like whatever. All the different variations you can think of, and you can get an LLM to be your thought partner. This is what you're doing, essentially. You're like thinking, okay, how can you explore the whole space of ways people can muck up the dates? The LLM.
This is why I connect so much of this work to discovery. If I want to, like, fundamentally what you're asking when you're generating this synthetic data set is, what are all the possible things I might expect from a real customer? And like, how do I anticipate what they might ask? And this is, I remember when I learned this in the class, Hamel teaches a very structured way for how to think about synthetic data. And immediately I was like, I don't want to make up my dimensions. I'm going to go talk to customers and figure out what their dimensions are. And so this is the area where I think there's a really natural hook into some of the things product teams are already doing to learn from their customers. And so it could start with, okay, what use cases are we covering? They need to find out, they need to schedule a tour. They need to find out when an apartment is available. They need to know when rent is due. These are all like date related use cases. But then I also need to understand my end user's mental model of how they think about each of those use cases, so I'm better at guessing what they might actually put into the agent. And then the humans are humans, so we're going to get things like, tell me about the 4-month rent. That maybe, I think, from a synthetic data standpoint, you'd have to go pretty wide to get. Like, I know when I did
you don't want to
data,
randomly, you really don't want to randomly do it. You want to have a strong hypothesis.
Like, I know when I did synthetic data, I was trying to look at, it's really easy to generate synthetic data in the way that you as the product team would think about it. All the variables, it's very structured, it's all very clean inputs. But what you really want is someone who doesn't have all your expert knowledge. What are they putting in?
Yes.
And that's where I think it's a little bit harder.
And I think, like, from the product perspective, what you want to do is you want to look at data, but you definitely want to also be talking to your customers. And you want those customers to help seed doubt in you.
Yeah.
And seed doubt, you're like, it sounds like this thing is broken. You know what? I'm gonna dig through. I'm gonna figure out. I'm gonna query these traces, because you can query the traces at large. You can search them, and there's different query languages and stuff like that. You can say, you know what? I'm gonna look for traces just like this, and when I find those traces, I'm gonna understand even more what is actually going wrong. You get another perspective in addition to your customer, which is always, or your user, which is always important, and then you can start to brainstorm ways that you can maximally break your product in that way that you have intuition that person revealed, but you can break it at scale. So because you have an LLM, you can say, okay, I'm going to stress test my system in all these ways that are derivatives of what that user told me, plus some other things I thought about. And then those become like test cases that you can iterate against.
I'm having a few thoughts at the same time about this. What I love about this, okay, so you saw evidence of an error.
Yeah.
You're now using synthetic data to understand the variations in which that error might show up. And so I think about this as like with qualitative research, we're trying to understand the variation across humans and uncover as much of that variation as possible. But what's nice about this is because you can generate that synthetic data set and then run the LLM against the agent against a synthetic data set, you're also getting a measurement. You're also quantifying how often does this error show up? And so it's the same activity is giving you both sort of the qualitative input of what are the edges of this? How does it show up? Where does it show up? But you're also getting the quantitative of how big of a problem is this?
Yeah, the synthetic data helps you, like, you can often like iterate on the product right then and there and say, okay, this is like, in the date thing, it was very obvious. In the beginning, there was no date. Actually, I think this data is potentially at that point in time where, yeah, there's the current date is not in this prompt.
Okay.
So there is no chance, an LLM has no hope. What do you, like, because in this case, yeah, it doesn't know.
Oh,
So if you say 2 weeks from now,
you're highlighting something that I think people miss. And I just saw this get written up about the Claude Code system prompt always includes today's date.
yeah.
And this is such a small little thing, but until you start working with AI products, you would probably never really think this through. An LLM doesn't know today's date unless you tell it.
Yeah. And it's not going to tell you, hey, you told me something to do something, but I don't know what today is.
Yeah.
It's usually not going to say that.
I think this is partly what makes working with LLMs a little bit challenging, is that there's so many things as humans we just take for granted. Of course we know today's date. In 2 weeks, we mean by mid-September, right? But the LLM doesn't have that context, and of course wouldn't have that context. And so this actually seems like a really good example of how you may not uncover that by just sitting in a room and thinking about, what do we need to tell the LLM? You have to look at the data and see, it's making weird date errors. Oh, because it doesn't know what today is.
Oh, you absolutely. I love that you said that, because that's the number one issue people have. They sit in a room and they brainstorm what an LLM needs to know. And they also sit in a room and brainstorm how to test their LLM. And that's impossible. There's no way you can do that. And it's also the same reason why you shouldn't buy a off-the-shelf tool and expect that it's going to show you your problems effectively.
Yeah, so I want to connect this back to where we started. Like you talked about in machine learning, you've got these input, your training data, then take production data, you're running it through this algorithm and you're getting output. And when you find an error in that output, you have to dig into the data and look at what was it about this instance's input? What was it about the black box? And that's what this trace is giving us, right? You're able to say, okay, we know that.
I can try to find an error if you would like, if that makes it more interesting. Let me see if I can scroll ahead and find one that actually has an error, just to be more interesting.
Yeah, while you're looking, I'll just highlight, I think the only thing that's really different from what you described in the opening is that we have an LLM that's like interpreting some semantics. But the overarching process is really that this could be a classifier from a big picture standpoint. And then the particulars get different with the LLM because LLMs have different abilities.
Yeah. Yeah, no, exactly. This is one that's interesting. So this is, if you recall, NurtureBoss, they also handle text messages.
Okay.
And you have a similar system prompt here. And then later on you have, okay, I don't even know what this means. I have been texting you all day. Hilarious. You can tell this is real data.
Yeah.
You can't make this stuff up. It's okay, I apologize for any inconvenience. There seems to be one major issue. I'm here to help Michael, blah, blah. My stepson Michael has filled out everything, not submitted yet, whatever. And you can tell the text message medium is broken, just generally, because the way people people text differently. Some people like to text very small snippets.
Yep.
And then break up their sentences into 4 or 5 different things. And early on, the AI was not able to handle that. It thought you have completed your thought. It didn't know you were breaking it up.
It would respond before the person was done.
It would respond, yeah. And so this particular issue was called, you can see they keep going in their conversation. This person was not happy.
I find I do this with Claude Code, right? I type something and I think I'm done, and then the LLM's off doing its thing and I keep typing, and it doesn't matter because it's not getting that input. This is actually a really interesting use case because we tend to think all of this is conversation, but we have very different conversational norms in different mediums.
There's a lot of problems with this thing. It's one, the mechanics are not working. Number two, probably should have handed off to a human much earlier when we found that the person was really agitated. Probably should have exited the workflow completely and handed it off.
This is a question I ran into with my own product. You see a trace like this, you've identified multiple errors.
Yeah.
What are you prioritizing?
So in this one, the heuristic is to, especially when you're starting out, to try to simplify things, because you can bury yourself in complexity. Yeah. You don't want to spend too long on any trace. you don't want to spend like 10 minutes on this trace. You want to try to spend like a minute or something like that. And you want to say, what is the overarching issue? Like, what's the biggest elephant in the room? And it's totally fine just to focus on that, because you're going to iterate on this thing and you're going to improve it. And being completely exhaustive is not necessary per se. You want to make progress like fast. And if you start to frustrate it too much by trying to document everything too much, then it's going to slow you down. So in this case, we just made a quick note. And there's a process called open coding. And so every telemetry product has this. So you can enter some open code like here. In this case, I actually stored my open code in this like thing. We just called it disparate messaging. So it would be some explanation like, yeah, you would just write it down. So disparate messaging seems like text message. You just write it down so that you know what happened when you come back and read it later. Or it's also importantly, if you send it to an LLM, you can figure out
it can cluster.
Yeah, it can cluster it. Yeah. So you might want to be a little bit more verbose.
I want to highlight something here because I had to learn this the hard way. So I took a class. In the class, several people asked, when you're looking at a trace that has multiple errors, what do you do? And both you and Shreya said, just document the first one you encounter or the worst one.
Yeah.
Right?
Yes.
And exactly this advice of don't spend 10 minutes on a trace. This really broke my brain. Like I wanted to be thorough with my traces. And I'm not going to lie, like for my first 50 traces, I literally wrote every error I found.
Yeah.
And it wasn't until I did a few loops that I realized why that was a waste of time. So I want to highlight that here for people who are like me. I want to be thorough. I care about quality. I thought the way to do that was to just do everything.
It's worth like hearing from you. Like, how did you realize it was a waste of your time?
Well, I'll also share like
more.
why I did this, like why I wanted to be thorough. Like for someone who cares about quality, like I want to get rid of as many errors as possible. And I thought if I document all of them, then I can get a good measurement and I can solve all of them. What I didn't realize is that like when you work with LLMs, there's not a straight line between things. So once I found my biggest error case and I like started to work on fixing it, it didn't just fix that error. It actually fixed a lot of other errors. And so it turns out like all that time I spent documenting all these errors that just went away. Like it wasn't needed. And I think after a few iterations of going back and forth, like if the error isn't going to go away, it'll still be there in that trace. And like in a future labeling session, you can catch it and you can still feed the monster of I want all the errors to go away. I just have to trust that like I'll get there in a future iteration. And I've started to think about this almost like bugs. So one of the very first blog posts I wrote like back in 2011, which was actually a really controversial blog post, was that you should, if a bug isn't important enough to interrupt your next sprint, you should just ignore it. And I know there's like different schools of thought on this. And I know like at Linear, they stop everything and fix every bug and they have an amazing piece of software. And so I'm not sure today I'm going to argue this is the right answer. But my point of view at the time, and I still believe the like underlying principle of this, is if this isn't urgent enough to fix to interrupt what you're working on right now, it's not going to be urgent enough next time. So like, why are you taking all the overhead to log it and to track it and to prioritize it? Just ignore it. And when it becomes urgent enough to interrupt your work, that's when you're actually going to fix it. And if it never comes up again, you don't have to log it and track it. If it does keep coming up, eventually it's going to become urgent enough that you're going to fix it. And I feel like this is a really good analogy for now that I have some iterations under my belt. I feel like that's how I feel about failure modes. If it's the 7th failure mode in the trace, it's not the most important one. I'm going to focus on fixing the most important one. And if that 7th one ever becomes important enough, it'll become really prevalent. It'll become really urgent, and it will become the next thing I work on.
Yeah, I think that's exactly right. That's really good. That's a really good way of putting it. Yeah, I 100% agree.
I think in my early days, I also had this belief that I'm going to do this error analysis, I'm going to write evals, and then I'm going to be done. And so if I just catch it all from the beginning, I'll get done faster. And now, like I wrote this in my August 20th blog post, like I had this really ironic epiphany. So like I teach continuous discovery, we're never done. And like my ironic epiphany was like my AI product is never going to be done. There's never going to be a time where I have no failure modes and I'll just check the box. I might get to a point where like it's good enough and my failure modes aren't catastrophic and they're not going to interrupt my work. But like this mindset of if I document everything, I'll get done faster is a little bit broken because I will never be done. And that's really helped me with, if I take a continuous mindset to error analysis and to evals and to measurement, then I can just focus on the most urgent thing right now and trust that the most urgent thing will always be the right thing.
Yeah. And this is one interesting, this is like my favorite error, by the way. So I'll show it real quick. So it's okay, same thing. We can collapse the system message. I guess it got cut off. Sometimes this happens. So it's okay. So there was some kind of conversation about the logging is messed up, apparently, because it's getting truncated, but that's a different issue. So this person is wanting to schedule an appointment. It's like, great. We have the available tour slots, blah, blah. So what is this? I'm not sure. This is for scheduling a tour. I'm in California. Thanks for sharing. I can help you explore whatever. I can schedule a virtual tour. And there is no virtual tour.
Okay. So this is a hallucination.
Yeah, this is a straight hallucination. Another issue is at this point, it should have handed off to a human. If someone's, in this case, shouldn't have just hallucinated something or the other, should have worked with them. Losing this person's is very bad, right? Yeah. This lead is going to go into a black hole. And this is definitely a scheduling issue. And the LLM has access to a tool called Schedule Tour. So it like actually goes and schedules a physical tour, and then it tells the user that like we have actually scheduled the tour, and here's like a confirmation, and here's all this information. So it looks like legit, but it's
it told the user it was a virtual tour when it's actually an in-person tour.
Yeah, and the same thing happened. If we keep reading the traces, we also found the biggest error. Another like huge error was rescheduling. You already have an appointment, but you need to reschedule. There was no reschedule tour. It would just keep scheduling like additional tours. And these are things that maybe we knew about, or we knew like it was a problem, but we weren't like able to. So we wanted to just count how many times are these various things occurring.
I was actually going to go here next. So I love that you just said that. I think that like when I first started doing my error analysis, I got really overwhelmed by, wow, my product doesn't look like it's very good. I'm seeing a lot of errors. But it wasn't until like I zoomed out and looked at my set of traces and started to count that I really had an understanding of, okay, yes, a lot of traces have errors, but a lot of them are not catastrophic errors. Like they're like minor preferences that I would have done differently. And then I could very quickly start to prioritize, these are my catastrophic errors where something really bad happened. And so I can ignore all that other stuff for now. Maybe eventually they'll matter to me because I've fixed all the other stuff. But like for today, what matters are the things that are occurring the most often that are the most catastrophic.
Yeah, exactly. So what we did is we took those notes, like you just saw. We went through whatever 500 traces or something, and we took notes. And then we categorized those notes using an LLM and categorized them. Actually, I did it in Excel. I just used Gemini in Excel. There's a plugin. And I just did a pivot table in Excel and just counted those messages. So that's the reason like I actually took a screenshot of the pivot table to drive home the fact that you don't need necessarily fancy stuff. And it's like, okay, there was like, so these are like the top issues. So like handoff to human, rescheduling, for example. And what they ended up doing, actually, I think this is interesting, is they ended up building their own annotation tool. So this is built by NurtureBoss. You can see built as this annotation grader. So took it out of Brain Trust and put it here where you could like add your notes. And then when you're done adding your notes, the system automatically categorized it and added, this is in a later iteration, added counts. So they decided they want to like semi-automate this workflow, and they wanted to render these traces in ways that made sense to them. Like you don't see, they hide the system prompt by default.
Let's just take a failure mode, like your date one. Like you uncovered in the NurtureBoss traces, it was struggling with dates. Like when I see that in my data, I want to go look at the traces that have that error, because I'm trying to build my intuition for how does this error show up? What's the shape of the error? How often is it showing up? That's probably informing my synthetic data to then get a better measure of that error, right? And there's the best way I can, like, the best analogy I have is it's like you're like looking for something in a dark room a little bit, and like you get a shape for something, and then you need to shine the light in another space. And when you get interrupted, it's almost like you have to start over. And so the less friction there is in your tools, the more you can stay on that path. And then I do want to go back to the nurture boss case, because like we just went deep on like you found a whole bunch of errors. I feel like for a lot of people, they don't want to do that work. They don't want to know what all the errors are. Like that's very alarming. My product's not as good as I thought it was. So what happens after that? Now that you've clustered, you showed us like your Google Sheets pivot table, you found your most common errors. Why is that helpful? Great, they didn't hire you to tell them their product wasn't very good. What did you do next?
Yeah. So now we knew, okay, like where do we focus? So we know these are the errors. And even before counting it, you've done so much error analysis, like you already know. Yeah. Before you even count, you're like, okay, I know whatever, handoff issues and date issues or whatever. And so now you like can prioritize, okay, now I'm going to go solve the date issue. So like, how do we iterate on the date issue? One is, okay, how do we measure that, first of all? And so for the date issue, it was, can we create synthetically a bunch of tricky queries and then the right answer of what the appointment should be, whatever. And in that case, the eval is a code-based assertion. You don't need an LLM. You can just check, is the outcome that the LLM is taking? If you can design a test, a stress test, okay, what should the appointment be? And like, is it calling the function? Those are all like deterministic outcomes. And so that's a code-based test of, okay, you can design code-based assertions like, does the date equal X for different use case, different, let's say, examples. And you can iterate. You can look at what percent of these like am I passing? And let me like fix the prompt and make sure that it has guidance on what to do. Let me make sure it has guidance what to do when it's like ambiguous or it's few or these are words that may not make sense. And you can keep iterating and go from there. And so that's one kind of eval, is the code-based evals. And the other ones, they're trickier. Like, hey, you should have handed off to a human because the person is not happy, or you don't have the ability to service this person, you should hand off to a human. That's probably more amenable to an LLM as a judge. And that gets into this whole topic of, okay, we need to assemble these like enough examples. We need to label that data of, okay, can we judge like whether or not a handoff issue occurred, and then go check whether or not it really occurred and make the LLM as a judge able to detect these issues.
Your LLM as a judge is almost a product in and of itself.
Yeah,
which is
it's very meta. It's like a meta problem.
Yeah, it's a rabbit hole you can go deep on. I want to go back to the date problem for a second, and then we can also get into the handoff error. But you said something that I think is really interesting, that when I took the class the first time, I got stuck on this a little bit, and I had to undo it and fix it. So you use synthetic data to generate a data set. And you use that data set to then run your like inputs and outputs. So your data set is your inputs. You ran your agent against it. You got some outputs. And then you wrote a code-based assertion to evaluate those outputs. Okay. So that synthetic data set that you generated is not like your dev set or your training set or your test set. It's literally just a set of data to help you generate outputs that you can then evaluate to figure out how often is this error happening. This really confused me because the first time I heard about evals, I heard that they're just a data set. And this is a way people do evals, right? They come up with like their golden data set. Here's a bunch of inputs. Here's the desired output. They run the LLM against those inputs, and then they score, did you give me the desired output, yes or no? And then that's their eval score.
Yeah, fundamentally, you're designing a test that you can iterate against, and you want that test to be hard enough to where it has value. so that you are making progress against it. In this case, the date situation is like, okay, it's very straightforward. Like we knew there's all these like edge cases with the dates. Okay, let's construct a test that we can just iterate on and see, okay, can we make it better? In that case, we didn't really need to do an eval per se because it was just so low hanging fruit. The main issue was that like the system prompt didn't contain the date.
Yeah.
But there was some other like minor things, but we just wanted to make sure, okay, we put system prompt, make sure the system prompt is fixed, mate. It's fine. Okay. So we just make sure we kill that problem.
Yeah.
In that case, we didn't need to do the full, let's say, eval because it was so easy to fix. But like the other ones,
it's almost like you had a temporary eval, right? Like you used your synthetic data to evaluate how often is the problem occurring. You fixed it, and I'm assuming that same synthetic data set allowed you to evaluate it was in fact fixed.
Yeah.
And then you can kind of just throw that away.
Yeah. You can get really scientific about it and say, oh, maybe you overfit to this. And you can do holdout and you can do all kinds of stuff. You can get more scientific about it. In this case, it was quick and it was okay.
Yeah. There's like an art to this of like, how do you know how rigorous to be?
Yeah.
Right? So do I need a golden data set for dates now that I've encountered this error? Or can I just try to fix it? And if it doesn't show up again, then I don't have to worry about it. Do you have any tips for like, how did you make these judgments? If you try to get rid of it and it goes away, or you're like, okay, I'm done. And then if it shows up again, you get a little more rigorous. Like what do those cycles look like?
It was just like, it's okay. So evals aren't free and you want to make sure that there's a cost benefit. Even in this case where the eval has been very straightforward, you don't even need an LLM as a judge, potentially. It was just such a dumb error, honestly, that it was like, okay, the thing is not in the system prompt. That's just dumb. Just fix it.
Yeah.
And then let's move on to the next thing. So you have a time budget, right?
Yep.
And we get a sense like we're not over engineering the prompt in a way that would cause something to overfit to some data. Because we weren't like putting examples in the prompt or anything like that. If we were doing that, if we started putting examples of dates and stuff in the prompt, then we would have to be really careful. Like we're not putting the exact examples of the data in the prompt. So it's this art that you get with experience. It's like a lot of things. There's rules, and then when you get really experienced, you can break the rules.
Yeah.
And in this case, like we're like, okay, we're making very minimal changes to the prompt. They're not specific to anything. We're just doing the sensible thing that we're just giving it the information that it needs to handle all these cases. So yeah, we didn't split out a test. That would have been like academic. But it's not practical. Yeah.
If it was that obvious of an error and the fix was that obvious, why write the code assertion at all?
Yeah, because the code assertion was like really simple to write. It was like just did it in a notebook and used AI, and it happened in like under a minute.
Okay.
And so it was just like I just want to think of all the other ways it could go wrong too.
Yeah. I think you're touching on something about what I really like about notebooks is that I have this idea in my head of like throwaway code versus like production code. And I think if I was in your shoes, I think I would have been curious about, do I really have a handle on this error? Like I would want to write the code assertion to just as a feedback loop of I'm thinking about this the right way. But like doing it in a notebook tells me like this isn't going to be a forever eval. Maybe it will graduate to a forever eval and it has to come out of the notebook. But it's like my scratch pad of let me just check my thinking. Is that kind of
it was like a scratch pad, check your thinking. And there's like other errors that were like, okay, these are going to take a little bit longer. So it's just, okay, it's very obvious. This is just this is basically almost felt like a bug. Like you forgot a comma. So like, whatever. Like, I'm just going to move on with it. It's probably not what you want to do when you're starting out with evals. You probably do want to maybe follow a process until you feel comfortable that you understand the process, and then you can break the rules. Yeah. But it's hard to hoist the full complexity of the thinking upon someone that's new to it, I would say.
Okay, let's talk a little bit about, and maybe we can talk about this in the context of the handoff one. How are you deciding? I know some people are using LLM as judges for everything. I think I've built a couple now that I know how much work is involved. I actually try to avoid them at all costs and only use them when I absolutely have to. Do you want to talk a little bit about how you make that judgment call, and then like maybe use an example to illustrate like why there's so much more work?
Yeah. So when it comes to LLM as a judge, unlike an assertion where you're saying like there is a very specific ground truth that you can assert, like 2 + 2 = 4, like the answer is 4, and you can test that with code. There's some problems in your LLM that might be like that way, like especially if you're doing classification or something. The thing I just showed with the Discord questions, I could assemble that into one if I wanted to make it really good, which I don't really need to. But if I wanted to make it really good, then I would create a data set that had like labels of is question, yes, true or false. And then you could hold out a data set. I could try to iterate on, okay, am I doing better on this dev set? And then if so, okay, let me just double check myself by also testing it on this data set I haven't seen. So like making sure I'm not cheating by iterating on this data too much. So in that case, like it's all about cost benefit. What does it mean by benefit? It's, hey, you need some structure in place to give you you need a feedback signal, because you know that you're going to have to iterate a lot on this problem. You don't even know how to fix it necessarily. You're not really sure. And so it's a little bit complex. There's no exact formula. Even with the code-based stuff, like the code-based evals are much cheaper. You do want to do those more often, but even then, like those still cost something, right?
Yeah.
Like in the example I was just telling you, it was like I knew I didn't even need that because I didn't need to iterate too much on that problem. So it's all about, you have to practice it to get the intuition, I think, is the best way I can explain it.
Yeah.
Maybe someone will come up with a better like framework or something, but it's really about, do you need to iterate this on this enough to justify an eval? And you just have to know like the cost of different evals, the LM judge being much higher cost than the other kinds.
There's a couple of things you said that I want to dig into a little bit. The first is around this idea of like how to set up your data sets. So this idea of a training set, a dev set, and a test set. I know you hammer on this in the course, and we talked about this at the very opening of this conversation about data leakage. And one of the key ideas is, if you, like with the LLMs in particular, if you use examples from your dev set in your prompts, like it's like giving the LLM the answer code. It's cheating, right? Yeah. And so you end up with this problem of overfitting, where the LLM is really good at answering coming up with the right outputs for your dev set, but then you go and you release to production and you don't see the same quality. And that's like the real problem here. Yeah. I wanted to highlight this because I rely a lot on ChatGPT and Claude Code to help me as I work. And actually, I noticed several times where both LLMs suggested practices that would have led to data leakage. And I had to correct the LLM. And so
that's really cool. Can you give us an example?
I would have thought, it was starting to pull out, like it was using my dev set to find examples to improve my prompts. And I was like, whoa, you can't use that question in my prompt because it comes from my dev set. Like we have a training set for that. And it'd be like, oh, you're right. That's a very common data science mistake. Let me fix that. But if I didn't know to push back on that, like I would have had pretty terrible data leakage. So I think this is a concept that maybe if you want to just explain the difference between these three data sets and like why they matter, because I do think this is an area where like even LLMs are giving bad advice.
So in machine learning, like we have these things, train, dev, test set. Basically, the idea is, just to make it more plain English, is okay, if you're teaching anything to anyone, or I shouldn't go as far to say anything to anyone, but if you're trying to make sure that a student is learning something, you want to have, it's useful to have like homeworks that the student can use to learn from examples. And it's useful to have a test to see if that student has generalized their knowledge outside of those specific examples. Because you don't want, it's like for a math test, to feel, you want to make sure that it's not just memorize those specific homework. That wouldn't do any good. And so that's the same concept you want to use, that same frame of mind for LLM as a judge. You're trying to teach the LLM as a judge to judge. And you want to make sure that it's generalized what you're trying to teach it to do outside of some specific data set. So that when it encounters new data set, here, when like this is the homework, this train set, this is the homework. And this is like the test. Even though it says test, maybe I should call it exam so it doesn't get, we don't confuse ourselves with terminology. But basically what you want to do is you want to use these examples to refine what the LLM judge does and use examples from your train set. And this can be like something like 10%. It can be a lot lower than machine learning. In machine learning, these percentages would be different. This can be like 10 to 20%. So this is going to be like 20%. This can be 60%. You can make this 20%.
Yeah, it's funny. I almost think about it as like the train data set is like the examples your teacher uses in class.
Yes.
The dev data set is like what you would do as homework. And then the test data set is like your exam. Because I think about it as what I take out of my training set is what goes in my prompts. It's how I'm teaching the LLM what good it looks like, what bad looks like. And then the dev data set is, okay, I'm testing like how good was the teaching, right? Give it my dev inputs, look at the outputs, how good did it do? Sometimes we get the homework wrong when we have to look up the answer in the back of the book. So we're going to change the prompts, change things a little bit. And then the problem, I think, correct me if I'm wrong here, but I think the problem with working with the dev set is as you iterate on how you teach the LLM, you might overfit to your dev set. And so the test set is a way to evaluate, did I make changes that only work for my dev set? Or do they work for examples beyond the dev set? And so like the test set, it's really important it reflects what you might see in production, because that's like did I really fix this?
Yeah, I like that a lot better. I like this articulation that you have. I think it's less confusing. So yes, exactly. So you can use examples. That's like the examples in the book directly basically uploaded to your brain. You're like, okay, you think you got it. The homework is, you can test, you can iterate on the homework and say, oh, you know what? In this case, you would be like designing better examples for, this is like where you write your prompt. You write your prompt based upon, so this is like where you write your prompt and you get feedback from the dev set.
Yep.
And you keep iterating until you're happy with the performance here on your dev set. And the thing is, the danger of doing that is that you might overfit to this dev set. So that's why you have this test set, so that you can check, okay, did you overfit to the dev set or not? You want to try not to. You're not going to try. So the way you would overfit to the dev set is if you actually pulled the examples directly from the dev set. If you pulled it directly into the prompt, then that would be a very clean sort of, or that would be the most blatant form of cheating. You cheated. Like you did the homework. You just, like you said, just looked in the back of the book. You didn't, whatever. And so just to help catch you from doing that. But the idea is you need this test, because at the end of the day, you need to know whether you can trust your LLM as a judge or not. And the only way you can trust it is if you test it in this. And that's why you need to hold out this data that you haven't looked at, so that you can get an assessment of how good that judge is. Because that's the question, that's the cardinal question that comes up all the time. Anyone has an LLM as a judge, be in a meeting room. So, okay, LLM judge score is 80%. All look at each other and be like, so what? Can we trust it? Is it good? Funny enough, a lot of people don't say so what. They just shrug their shoulders and move on to the next thing and whatever. But that's when you get into trouble.
Okay, right? So I want to unpack this a little bit, because I think this is a really important concept. Like, you have an LLM as judge that's judging the output of your agent. And so you want to know, is the judge doing a good job? If it tells me the agent does a good job 80% of the time, I want to know, does that align with how I would think about it? Do I actually think it's doing a good job 80% of the time? And so as you're iterating on your LLM as judge, your training set is where your prompt examples come from. You're looking at your dev set and the performance of that judge on your dev set. Maybe you're seeing like 30% of the time it fails. It doesn't evaluate correctly. So you're looking at those 30% in your dev set and you're looking at, oh, it has a problem with these tricky scenarios. Let's update our prompt to fix those tricky scenarios. And then the danger is that like maybe there's some other tricky scenarios in your test set that aren't in your dev set. And so like you score your dev set and maybe it looks like it's 80% good. But when you score your test set, it's only 60% good. So that's an indicator that you overfit to your dev set.
Yeah, definitely. Yeah. So if your train scores, and we're simplifying the scores, which, we can talk about later, but say you scored 90%, whatever that means on your train set. In your dev set, you scored 80%. But your test set is like now you scored 10%. That means you probably overfit. To your dev set. There's always going to be some amount of overfitting to your train set because you have used it in examples.
Yep.
So whatever. But you don't want the delta. You want to try. So how do you avoid overfitting in the first place? So this is like where it gets into data science thinking a lot. So like one early signal is you don't want the delta between these two to be that high. If you already started overfitting on the dev set, because like now, let's say the score of this is like too high, then that you might become skeptical and say, oh man, I'm probably overfitting to my dev set. There's a lot of other things that there's other techniques you can try to use to see, but the ultimate test is like what is it on the test set, because you're only peeking at that once. And so you can't, if you're diligent about setting it aside and all that stuff, then you shouldn't be able to cheat.
Yeah. And do you do the same process? Let's say we're talking about this in the context of an LLM as judge, but do you do this same process? Let's say you're A/B testing a change to your agent.
Wait, say that one more time. If I'm A/B testing,
like let's say you're like right now we're talking about like prompt changes for an LLM as judge. What if I'm making a prompt change in the agent itself, like in the nurture boss, like system prompt? Would I want to evaluate that prompt change in the context of my dev set? And then only when I see that like it's having an improvement, run it against my test set?
Yeah, I mean, you can apply this to, it's a little bit interesting question because you can apply changes to any part of your LLM and then run it against your evals and see like what's going on. This is like an acute problem though for LLM as a judge to make sure because you're training like a model in that case, and you want to make sure that you trust it. With the agent, you want to see again if the cost benefit is there before doing this. That's why I'm hesitating answering. Like, it depends if you need. So if your agent is doing something wrong, if you're trying to make a change to your agent, if there's a specific failure mode you're addressing, then you probably want an eval for that. And then you want to decide whether or not you do the segmentation. If it's just like a routine change or some kind of other change, hopefully you have a suite of evals already there that you already trust, and you can just apply, and you can just run against that agent on some data that you have. And that doesn't have to be, you don't necessarily have to do it like this. You can just have some held out data set that you refresh on some cadence that, because you will overfit to that data set also.
Yep.
So let's say you're making changes to agents or making changes to anything. You have some data you hold aside. What we teach in our class is, okay, you have CI/CD and some automated tests you might want to run. And what you often do is you have a very curated data set that you run a battery of tests against. And so if you make a change to an agent or something like that, you definitely want to run those tests against that curated data set. And you want to refresh that data set over time. Because number one, it's going to get stale. Number two, like you will slowly start overfitting to it because you keep doing tests on it and whatever.
Okay.
So that does exist. That this thinking you should always be paranoid about overfitting.
Okay.
The cost of not, you can get super academic about it and be like, no, you should never use one data more than once.
Yeah.
The only problem is that gets infinitely expensive.
Yeah.
And like, we don't have infinite resources. So from the more pragmatic perspective, we have to do is think, when do we want to defend ourselves against overfitting?
So it sounds like in the context of an LLM as judge, we want to be able to trust the judge. And so if you have an eval that is important enough to have an eval in the first place, so that's already like one filter. A lot of error modes, you may not even need to have eval at all. And then if it's important enough that we're going to have an eval, and that eval needs to be an LLM as judge, we want to be able to trust the judge. So we're going to go through a little bit more rigorous process to make sure that judge is aligned with our judgment. We're going to hold out a test set so that we can walk away having confidence in that judge. But it sounds like for experimenting on the product itself, let's say in this case on NurtureBoss, it's not necessarily that you have a dev set and a test set. It's as part of your CI/CD pipeline, you're running the change against almost like a golden data set that you've curated over time. And that really the important thing is that data set stays fresh, because it'll go stale in terms of representing what in production, and you do run the risk of overfitting to it with time.
Yeah, so it's two really data sets at that point. That's like CI/CD. This is the curated thing. And then there's your production data, which is just like the traces that you're collecting in production. And you can run your evals against that as well. You want to try to catch it here first. Obviously, before you go to production. But you also want to run those evals against your production traces in case like you're just to allow you to catch things that you didn't catch in CI/CD. And then like you can use that to update what's in your CI/CD.
I think one of the big risks here, and this is something I struggled with at the very beginning, and I still struggle. Like I'm a worrier, so this is the thing that I worry about, is that like your CI/CD set is only as good as it is diverse, and only as good as it represents what in production. And so this idea of maybe you run your evals on a percentage of your production traces, or if you're low volume, maybe you run them on all production traces. There's there's a cost trade-off, right? Like evals don't come for free. And so it's what's the right balance to make sure that CI/CD set is representative of what you're seeing in production and isn't getting stale, but you're not running expensive evals on every single thing and like tripling, quadrupling your cost.
For the production case, like you definitely want to sample here in most cases. And then here, this is just like smart curation. And you want every test case to be adding value. It's okay if there's things not adding value. So if you've passed a test and you've been passing it for a long time and you feel like that's just like a really dumb thing, and it depends like what the cost of running that is, you might decide to phase it out. It's a little bit different than like software testing because it's not like free.
It's not free.
You have to make a judgment call at some point. Okay, what do I want in the CI/CD? And it's helpful if your CI/CD has like broken things that you don't know how to fix, because it just provides a lot of healthy pressure to have broken things in the CI/CD. I find it's okay. You don't get that satisfaction.
So you don't fall into this trap of like, all our unit tests pass, we're fine. Our integration tests pass, we're fine.
Yeah.
It's like a reminder your AI product is never really done.
Yeah.
I think we're hitting on maybe one of the hardest things for people, and especially non-technical people, to wrap their heads around. I can't tell you how many times I've heard someone say, we did this little prototype, it showed promising, it was promising, and now our executives want it launched next week. And like, they're struggling with understanding there's edge cases that aren't even, the edges are big. They're not like stochastic, they're not like deterministic software where the edge case may come up like 0.001% of the time. And it's safe to release with that edge case. It's that you could have an error that's showing up 17% of the time. And I think that it's probably everybody in business has a big learning curve to wrap our heads around what good even means in the context of a non-deterministic product. Like maybe we all need to learn how to start thinking like data scientists. And then I think for people on product teams, we need to learn how to communicate this better. So I like this idea of having broken cases in your CI/CD set so that you you get continuous reminders like we have to revisit this.
Yes, it's like an extension of the idea that your metrics dashboard for your AI should not all be like 100%. Otherwise, it's just like dead weight. It's like providing no value. It should always be some indication of like, where can you improve? That's the whole point. It's not like to pat yourself on the back. Yeah, that's why I try to bring this into the CI/CD. It finds that it brings people a lot of pain to put it in CI. Say you're failing in CI/CD, which is exactly why it works.
Yeah, that's great. All right, this is very quickly becoming our longest episode ever, so I think we should probably wrap up. Hamel, obviously a fountain of knowledge, especially when it comes to error analysis and evals and just how to do this stuff well. If folks want to learn more from you, where should they go? What should they do?
Yeah, so one good place is my blog. I write a lot about evals, and there's a lot of wealth of information there, including like frequently asked questions about people have. We've collected a lot of them from the course. There's too many to go over in one session like this. And then also the course, like please check out the course. We go through all of this in a lot more detail and answer all kinds of hairy questions about how this works in practice and show you. So yeah, please check out the course.
And the course is AI evals for engineers and PMs on Maven. This has been amazing. Like I said, a fountain of knowledge. I'm sure we'll probably get you back for a second conversation at some point because it's always a lot of fun. Thanks for being here.
All right, thank you for having me.
If you enjoyed this conversation, please subscribe in your favorite podcast app and give us a rating as it helps others find the show. Thanks, I appreciate it.